let's blast through with the no voltage because we've seen no voltage a few times. So I'm gonna put my ground. It was drawn. I'm gonna put it back. It was right there. Okay. We're gonna label our voltages. I'm gonna go plus minus. I'm gonna go plus minus. Oh wait, not voltages. Excuse me. I'm gonna label currents. We're gonna go like this, and like this, right?
Mm-hmm.
And now that we have those labeled, we're gonna create. We're gonna give names to our nodes. So we're gonna name this node A, node B, node C. And that's all we need. Okay, so it's gonna give us 3 equations. Actually, it's just gonna give us 2 equations. One of them is a supernode. All right. And so from here, we've labeled our circuit. All we got to do now is the next thing that we do is what? So that was step 1. We finished step 1. What's step 2?
Analyze the sources.
Good. We look at the voltage sources. We got a 12-volt source. And so the moment when you get really, really good at this, you'll just automatically put that A equals 12 volts.
Yeah, I figured
you'll start getting really good at it. You'll put A equals 12 volts, and then you'll say for the 24-volt source, you'll put that C minus B. Is it B minus C or is it C minus B?
It's C minus B.
Good. C minus B equals 24. Do I have to divide anything? Do I have to do C minus B divided by 40?
No, it's not. There's no resistance between the 2 nodes.
Good. I'm only asking these questions so that I'm like pinging your brain to always remember.
Yeah. I figured. I remember the C and B thing because the plus should go towards the C and the minus goes to the B, so it's C minus B equals 2.
Good. No, and that's perfect. That's perfect. I do the same exact thing. So we got that. Step 2 is done easy. Last step is what? What do you have to do now?
So would we want to find the voltage? Will we use that 10 ohm resistor to find the voltage of B? Node B or supernode?
Yeah. Because it's not solved. This one's solved. A is 12. If you have a voltage source and it doesn't solve, it gives you an equation, automatic supernode.
Yeah.
So once we hit that situation, we got to do step 3, which is do KCL. We got to do the current law. Now, we can only do the current law on nodes B and C because node A is done. Node A is good. Like node A has been figured out. Put a little check on it. So what's left is B and C. But the thing is, B and C are both connected to our source. So that's going to be our supernode. Make some sense?
Yeah. Yeah.
So I'm going to put a bubble around it. Supernode BC. And with that, we have to look at the currents going into and out of it. So we'll take a look at this guy, this guy, this guy, and that guy. You see it? So that's 4 currents. A lot of the time, students are actually going to get messed up by that. And I'll tell you, typically what students will get, students will see this one. A lot of students will catch this one, and they'll forget this one because they don't realize that the current source is a current. You see what I'm saying?
Yeah.
So just be very careful of that. What I like to do is I don't look at the actual, sometimes I don't look at the actual currents in themselves. I just look at the lines touching it. So I'll go 1 line, 2 line, 3 line, 4 line, and I go, there have to be currents in those lines. You see what I'm saying? So that's how I look at it. I don't look at if there's an arrow going to or away from it. I look at the fact that there's a line actually going in and out of it. And I say, okay, there has to be a current associated with it. So it helps me remember. So that way I go, okay, if that line's touching it, then that source has to be working. If this line's touching it, then that has to be the current that it goes with. Does that make some sense? So that's how I like to think of it. And that way I don't miss it because it's very easy to miss a line on the supernode. And if you miss a line, you're going to mess it up. So we're going to do the supernode equation.
A cool question. So is R1 and R2, right? Are those 2 in parallel or no?
They're not in parallel. R1 is between A and B. R2 is between B and the ground. They don't share the same 2 nodes. To be in parallel, you have to share the same exact 2 nodes.
Okay.
So there's nothing in parallel with R1, and there's nothing in parallel with R2 because every other object on this circuit is between two different nodes. And that's the only definition for parallelism. A lot of people think it's like, oh, they're next to each other, so they're parallel. No, that's not how it works. I can make something next to each other and it won't be parallel. And I can put two things on opposite sides of the circuit and make them parallel. So it's all about what nodes they're connected to. The only things that are in parallel are these two guys. And I'm not going to do it. I don't need to do you could source transform, but there's no point in doing a source transform if I can just do no voltage method. So first we'll handle this guy, which will be, what is that, A minus B or B minus A?
It would be B minus A.
We're talking about this one right here.
Oh, A minus B.
A minus B. Start minus stop. It starts on A, minus, stops on B, divided by 10. Boom. Is it positive or negative?
Is it positive or negative? It's going into B. Positive.
Good. So it's positive. Then we're going to do this guy right here. Is that going to be B minus ground or ground minus B?
B minus ground.
Good. B minus ground is just B divided by 40. Is it going to be positive or negative?
Negative.
Good. Negative. Boom. Then we're going to do this guy. What's that guy going to be?
0.6.
Mm-hmm.
Plus.
Good. And then last but not least, tell me what this one will be.
That one, that's connected to the ground too. So it would be C minus ground, which is just C over 40.
Good.
And it's leaving, so it's negative.
Perfect. 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 Absolutely perfect. Multiply everything by the big 4-0. And then let's see.
Couldn't you just multiply it by 4? Like A minus B by 4?
If you do it by 4, you won't get rid of the full 10. So you got to do it by 40. But what's going to happen is when you multiply by 40, you're going to get 4A and 4B. Minus B plus 0.6. 6 times 4 is 24. So this would be 24. And then this would be minus C equals 0. Then you're going to get negative 5B minus C equals negative 24 minus 12 times 4 is 48. Because remember, this guy is 12, right? It's a lot of negatives. Since they're all negative, I can make them all positive, which is convenient. And 24 and 48 are going to give me 60 plus 12, which is 72. All right, dope. And so now you have one equation here, one equation here. You just got to solve them. Okay. So solve system. You're gonna subtract the two from each other. So it would be 4B equals 72 minus 20 is 52 minus 4 is 48. B is 12. Okay. Then you also get once you get B is 12, C minus B is 24. A number minus 12 is 24. That means C has to be 36. And those are your voltages. So A is 12, B is 12.
Wait, so how is it 4B if you're subtracting the two of them and then it's a negative B there? Wouldn't it be 6B or no?
Oh, you know what? You're right. You're right. You're 100% right. I did it wrong. I'm trying to do it all in my head. It would be, I'd have to flip the top one, so it'd be 6B. 6B equals, and then I still have the 48.
The same process, yeah.
And that's going to give me B equals 8. It's funny because I was actually looking at these two just now. I was saying if A is 12 and B is 12, that means that actually shuts off the that's going to shut off the resistors, which would have been weird. So I'd have to relook at it to make to try to check it. So B is 8, which means that C is 32 and A is 12. Bam. So now I got my answer set, my solution set, but that's not the answer. But I'm going to have it right there. And so I need to know the power supplied by each of the sources. All right, so I want to know the power supplied by each of the sources. What's the equation for power?
Isn't it V times R, right? Or is it I squared times R?
Don't use the resistor one. Use the general form of power. Because a lot of people go, yeah, it's V squared over R. Or I squared times R, which is true, but look at these. They only use R. So that means that those are only the representations of power for a resistor. I want the general form of power, IV.
Oh, yeah. Right.
And that's going to take into account all every object, anything that has, well, any element can now use that form of power. So now I want to look at the sources. So first we're going to look at the 12-volt source. And so we know we need IV. So power is going to be, the voltage is 12. The current, what's the current? So let's take a look at this. Zoom in a little bit. The current passing through this 12 volt, where is that current going? What is it passing through?
A.
Good. It's passing through A, which means that that's the same current that hits that 10 ohm resistor. Make some sense?
Mm.
So I don't necessarily I don't know the current going into A, but I know the current going out of A, which is the same exact current. So it's like saying, I may not know how to look at it. I may not be able to recognize a penny from the tail side, but I know how to recognize the penny from the head side.
Mm-hmm.
And so there's not an equation for the current for a voltage source, but there is an equation for the current for this resistor. Make some sense?
Mm-hmm.
And so that's what we have to plug in for the current passing through the voltage source, because that's the same exact number. So we're going to use the current representation being, say it.
Would it just be, it would be A, the numerical value A minus B over 10.
Yup, that's exactly right. A minus B over 10.
Because we found both of them. So.
Come on, work for me. Over 10. A is 12. B is 8. So that's 4 over 10. So that's going to be 48 over 10. Oh, it's just 4.8 watts. Dope. Same exact process for all three. So we're gonna do the 0.6 amp next. So we do 0.6 amp next, and that's gonna be power equals the current, which is 0.6, but now I need the voltage. So take a look at the 0.6 amp. Can you tell me what the voltage on the 0.6 amp is?
24.
Are you sure?
I mean, if it's a SuperNode, wouldn't it be, or no?
I see what you're thinking. I like it, but it's not right. So look at this. I'm not gonna lie. The trickiest part about circuits, you only figure out how to do circuits by watching someone do a bunch, and then by having to figure it out on your own after watching somebody do a bunch. Like, I didn't realize how good I was at circuits until I'd already finished all of my electronics, until I was like at the end of my degree. Remember I told you I almost failed each one. The only reason I realized it because I watched my teacher do so many that it started to soak in. So what you want to do is you want to look at the voltage here, the plus and the minus right there. Make some sense?
Yeah, so for C is, so would we just do C then? 32?
Yes, 32. It's going to be VC minus V ground. That's the voltage on that source. Make some sense?
Yeah, I see.
And that is going to be 32. And that's how we know what the current is, what the voltage is there.
Okay, that makes sense. I can see that.
3 times 6 is 18. 2 times 6 is 12. That's going to be 19.2. That's watts. Oh, something that I'm neglecting, and I'll show you at the end. Just remind me. Say you forgot a negative, and then I'll show you. I just want to get done with this this last source first. So then last but not least, we have the 24-volt source. And let's handle this guy. So power. Now this one's, I think, the more difficult one just because of what's happening with it. Power equals. So remember, when it comes down to the 24-volt source, it's between two nodes, right?
Mm-hmm.
So we have to figure out the current passing into it. So there's a current going like this. We have to figure out what that is. Do we use B, C, or both of them to figure out that current?
I'm sorry, ask the question one more time. I think the Wi-Fi was going out.
That's fine. We're looking at the current passing through the source, right?
Mm-hmm.
Are we going to use B, C, or both of them to find that current?
Both of them?
Nope, I got you. You use either one, but not both. Because if you look at B, it's these three currents interacting with B, and I can say this guy minus this guy equals that guy. Or
you could do C, which is that guy minus that guy.
Yep.
Okay, yeah, I can see that. I would pick C though, just because C's simpler.
That's fine, and that's what we're gonna do. That's exactly what we're gonna do. But if you try to do B and C together, what you'll end up having is, and you can do it. You could say this guy minus this guy plus this guy minus this guy equals this guy, but I wouldn't try it because I'm actually not sure. So I'll try it at the end just to do like a math check.
Logically, it makes sense because because in my head, the way I would have did it was then I would have got whatever value I had for C subtract from B. But it's like if I know the values for C and B, like it's redundant to try to do it that way. I guess.
Yeah.
Like think about it now.
Yeah. So let's run it like that. So we know the voltage is 24. And then we know we got oh man, A is going to be, oh, you said you wanted to use C. So C is going to be 0.6 minus
C over 40. Right?
Hold on. I'm sorry. I'm having a brain fart.
You're fine.
Okay, because that current will be like this. I'm just gonna, whenever I have a brain fart, I just write the whole thing out somewhere else. It's gonna be I through the source plus 0.6 equals VC over 40. And so I'm just gonna solve that. That way I won't kill myself. See, so I would have actually written it wrong because I need to subtract it out. So I got VC, which is 32 over 40 minus 0.6. 32 over 40 is 3.2 over 4. That's not going to work. That's going to give me 16 over 20, 8 over 10, 4 over 5, which is 0.8. 0.8 minus 0.6, which is 0.2. That's going to be 0.2 right here. 24 times 0.2 is going to be 48, but with a decimal here, and that's going to be watts. Dope. So that's our guy. And I have to explain something. So did you understand how we got these three answers?
Yes.
Great. So those are our answers. I just have to put a negative on them, and I'll show you why.